All right, hey folks. So my name is Todd Kloots. I work for Twitter. I'm here to talk to you about pushState today, specifically our implementation of pushState. I'm sure you've already noticed that I have a URL up on the screen, and this is all the slides for today's presentation, so that if you have any trouble seeing any of the sometimes tiny text on the screen, you can download that in advance and get a better look at some of the diagrams that I'll be showing, or just use it to browse ahead, formulate questions at the end if you like. So like I said, I'll be talking about pushState, and it's worth noting that I was one of several people at Twitter working on our pushState implementation that I'll be talking about today. Those people were, including myself, Dan Webb and Kenneth Kufluck. And if you'd like, beyond today's talk, to dive deeper into our implementation, we wrote a blog post about 6 months ago on our engineering blog that gives even more details on our implementation. So you can check that out, and the URL to that is also in the slides on SpeakerDeck. And to sort of set the stage for what I'm about to talk to you today, I'll give you sort of a brief summary of what our implementation entails. It effectively is progressive Ajax using server-side rendering. So specifically, what I mean by that is, regardless of how the user is navigating twitter.com, whether pushState is enabled or not, we're always rendering our view server-side, and should the browser be capable of using pushState, we then facilitate that navigation via Ajax, and we use the history API to update the entries in the history to reflect the current state of the application. So that is, at the highest level, a summary of sort of the implementation that we have and what I'll be talking about today. So from our vantage point at Twitter, we saw the history API and pushState, specifically the primary benefit of giving us the opportunity to speed up navigation between sections of our site, but to do so in a way that was completely transparent to the user. And it's that second part of that sentence, that transparent to the user part, that up until somewhat recently wasn't really possible. So if we set our time circuits, for example, back to as early as January 2010, when there was no support for pushState in any of the major browsers, and we had the same goal that I was just talking to you about before, which is to render our view server side and use Hijax or progressive Ajax to facilitate navigation between sections. Our implementation would look a little bit different than what it would with the history API. So this will give us a little history on what led us to the formulation of the history API that we now know and use today. So before the history API, if you wanted to facilitate this sort of navigation and you wanted URLs that mapped to the current state of the application, you'd probably have to do something a little bit like this, where the user clicks on a link on your site. Let's say it's twitter.com. They click on the connect link. Some JavaScript on the page is going to hijack the click on that link. It's going to prevent default. It's then going to make an Ajax request for that specified path. And then you're going to take that view, render it on the client, and then lastly, in order to have a stateful URL, you're going to throw the current path behind a fragment or a hash in the URL, so as not to forcibly reload the browser, but have a URL that is mapping to the current state of the application, right? So this was sort of born out of necessity, this approach, without the HTML5 history API being in place. Unfortunately, though, this approach did come with some consequences, one of them being that for every URL that you want to provide Ajax navigation for, you would be introducing a new URL for every existing endpoint you already have. So if you just take a simple example of that, like the user can type in the path to our connect URL on Twitter, or they could find that via Google or whatever, but they could also be on Twitter and navigate to that via the aforementioned path. And because of that, there are now two URLs for that same endpoint. There's the hashed version, and then there's the old school quote-unquote version. And this problem of multiple URLs gets slightly uglier when you consider the fact that the user might not start on the home page of your site or application. They may start on our Connect page, for example. If you take Twitter as our use case, they might start there, then click to our Discover tab, and the same navigational flow is going to then take effect, where we make an Ajax request for the Discover content. That request comes back. We'll render the view, and then lastly update the URL. But now, because the user started on Connect, the hash gets thrown behind the URL that the user started with. In this case, so it would be i/connect, and then the hash and the path for the Discover page. So that's what your location bar would look like if you were using hashes. Now, as a developer, you could help mitigate the user seeing this level of ugliness by redirecting the user the minute they hit your site for the first time. But when you consider the goal of transparency and this notion of a good user experience, this is going to introduce slightly more latency for the user. It's also going to give the user the experience of, oh, I just typed in this URL, now it would change without me actually doing anything. So the user experience is slightly less than great. And these aforementioned issues, as well as a host of other issues, are with respect to using hashes for stateful URLs with respect to Ajax navigation, are really, really nicely documented in this article on GitHub called Intelligent State Handling. And it's authored by this guy, Benjamin Lupton. And if you are considering using hashes for stateful URLs, or if you're just interested in the history that led us to the development of the HTML5 history API, this is a really good read. But thankfully, we live in the future. So let's set our time circuits back to today. We'll travel forward in time again, where we have support for the HTML5 history API. And so if I could just summarize the API in a nutshell, it gives you, the developer, the ability to either add or modify existing entries in the history so that they reflect the current state of your application or website. And it does that in a way that doesn't require the browser to reload the page. So no forceful reloads, but also allowing you to modify history entries. So if we now revisit the same user flow that we just went through with hashes, but now using pushState, this will give you sort of a clearer picture of the value that pushState provides. So the user starts on the Connect tab. The user starts on the home page of Twitter. They go to navigate to Connect. The same thing kicks in. We hijack the click on that link. We make an XHR for that content. Comes back, we update the state, but rather than throwing the URL behind the hash now, what we do is we call pushState, and that allows us to update the URL to reflect the new state and add a history entry for that state without forcibly reloading the page. And the nice thing about this approach is the URL is exactly the same whether the user has navigated there via pushState or whether they have, or whether the browser doesn't support pushState. So the URL, you have one set of URLs for every endpoint on your site. A little bit of a deeper dive into what the pushState API, or the pushState method rather, looks like. So it has 3 arguments. The first is serialized JSON that represents the state of the given entry in the history. The second is a simple title that you can use to title that entry in the history, typically what you would see when you look at the history menu in your browser. And then lastly is the path or the URL that you want the browser to have that corresponds to that entry in history. It's worth noting some small gotchas with this method. We found, for example, in Firefox, because the state object is cached to disk, they impose a 640K limit on the serialized JSON that you can push into the history. We hit that fairly soon in some of our cases, and so rather than use disk to store our state, we just store it in memory in JS. The other interesting gotcha that we found was that most browsers don't do anything with that second argument that you passed, which is the title to the history entry. So as you're updating or adding entries to the history, if the user presses and holds their back button, for example, or goes into their history menu, they will see history entries reflective of their original point of origin only, and they'll see like a number of those for every entry that you added, and they won't see something more meaningful, which is that the titles that correspond to each entries in history. So in a nutshell, Opera and Safari get it right. All the other browsers don't do anything with that entry currently, and so the user experiences with respect to the history menu itself is not that great in those other browsers. Okay. So let's continue forward with navigating around twitter.com using pushState. So we've already gone from twitter.com to the Connect tab, and again, we facilitated that navigation via pushState. We can then navigate from Connect to Discover via the same means. So we'll hijack the click on the link to Discover. We'll make an Ajax request for the Discover page content, update the view, and then call pushState to add an entry in the history for that particular page that we've navigated to. And now the user wants to go back in time. So they're going to hit the back button. And what's going to happen there is the browser is going to fire a popState event. And the event object is going to have a state property on it. And that state property is going to map directly to the object that you pushed onto the history when you called pushState, and the user navigated to that URL in the first place. So to paint a clearer picture of that, and again, this is where the downloadable slide deck might come in handy for those of you who are in the back and can't see this very well. But when we pushStated to connect, we passed in the connect page's data. When we popState, e.state is going to be equal to that first the value that we passed into that first argument. This is a little easier to read, hopefully, and just another sort of underlining of the same point, but this time in code. If we're going to pushState to a URL foo, and the associated state object with it is just foo set to true, when you receive the popState event, when the user is navigating back to that URL, e.state is going to be equal to what you passed in. Okay, so we're almost back to our original point of origin. We're on the connect page. We're going to hit back again. We're going to go back to twitter.com. Now, what's interesting here is your popState event listener is going to get called again, but the state property is going to be null. And the reason for that is because the user initially navigated to that first page, but they didn't do that via pushState. So there's no state object in the history representative of that particular point in time. So this is where there's a second piece of the API here that you can take advantage of to fix this problem, which is called replaceState. So unlike the pushState method, which allows you to add entries to the history, the replaceState method allows you to modify existing entries in the history, and it has the exact same signature as the pushState method. And so what we do on Twitter is before we kick off our very first pushState navigation, we detect that this is the very first time the user is pushstating, and we call replaceState, and we knit together a state object on the client representative of what that response would be like had the user navigated to twitter.com via Ajax, and then we overwrite the existing history entry so that when the user clicks back all the way back to the original point of origin, that our popState event listener, has a state object associated with it so that we can use to reconstruct state. So that is a high-level overview of the various pieces of the pushState API that we use, or the history API rather, that we use, and like I said, we found that one of the nice benefits to this is that we were able to, because we didn't start with an implementation of twitter.com that was specifically designed around pushState, we could implement pushState in a way that was transparent to the user because our URLs across the site didn't change once we introduced pushState. We also found another benefit to using the HTML5 history API, which is it allowed us to speed up navigation between sites that was not between sections of our site rather, that was not only done in a way that was transparent to the user with respect to the URLs of each endpoint, but it also saved us from having to re-architect our entire application around Ajax navigation. And this is a point I think is often sort of either lost on developers or that people don't think of right away. A lot of people think, I'm going to be using the HTML5 history API. That means client-side rendering, really like granular state control on the client. But that's not what we did. And it's not to say one approach is bad and one approach is good. Everyone has the approach that is best suited towards their application. But if you're interested in learning more about how we did it, come with me now back to the 90s. So I'm somewhat of an old-timer, and when I was first coming up in the field of web development, there was this design pattern for the web called graceful degradation. And the way this would guide your development as an engineer or designer would be that you begin by sketching out your requirements for your site or application, assuming best-case scenario. Best browser at the time, which probably would have been like IE5, IE55, and then after you've got that all sketched out and you figure out how you're going to implement it, then you think, okay, now we need a strategy for Netscape 4. We need a strategy for older browsers. We need a strategy perhaps for accessibility. And so one of the sort of hallmarks of this style of development were things like specific user agent detection, developing text-only versions of sites. So the end goal was that we don't want to be completely exclusionary as an application or as a site. We want to be able to give the user some sort of experience, but it ends up being a significant cliff of experience from the ideal that you began architecting. And so if we look at implementing pushState through the lens of graceful degradation, something like browser support for pushState is going to be like really, really top of mind. And we're going to be, because again, we're going to likely be architecting our whole site around pushState, and we need to be like aware of what browsers support it and what we're going to do if browsers don't support it. So that's one approach, but that's not the approach that we took. We took the progressive enhancement approach. And the The way that progressive enhancement is different is it's sort of a complete inversion of the graceful degradation design pattern. And so for those of you who are not familiar with progressive enhancement, what you do is you begin by saying, what is the baseline level of functionality we want our site or application to achieve? And then what do we want to then layer on top of that baseline functionality so that the browser can take advantage of these different tools and APIs that it has, because the browser is the one that knows what it's capable of, and then the browser can like up-level itself as it's capable. So if we were to look at pushState through the lens of progressive enhancement, as we did at Twitter, we sort of outlined our core functionality as follows. So the user should be able to navigate between sections of the site. That seems fairly obvious. Ideally, that navigation should be as fast as possible. So using progressive enhancement, pushState is now one of those tools for as fast as possible, but it is not the only tool. And URLs should be accessible regardless of the browser's abilities. And this was really important for us because we often think of Twitter as a conversation happening in the public square. So we want to inhibit, as much as possible, access to that content. So the conversations that are taking place on Twitter are accessible to the widest possible audience of both humans and machines. So looking at pushState support and HTML5 history API through the lens of progressive enhancement, you're somewhat not necessarily concerned with browser support for the API because you know that the browsers are going to get there eventually. And as they do, they're going to be able to take advantage of the new technology, but at the same time, you've built this core level of functionality that the user can always fall back on regardless of the client's abilities. And so what we found is that progressive enhancement as a design pattern really helps you curb your enthusiasm for new technologies as they become available in the browser, because I think that I can definitely speak for myself that sometimes like you see new APIs emerge and you're like, oh my God, I can't wait to use this, I can't wait to implement this, and then like every problem becomes a problem that's now solvable with this one thing. And if you sort of like take a step back, calm down, curb your enthusiasm, and you think about it as one means of achieving an end versus like the only means, then I think it helps you to think in a way that's building things a little bit more robustly, sometimes more simply. And again, this is the approach that we took for Twitter.com. And we saw a number of benefits going through this exercise. One is that we were able to reuse our existing software stack on the server. We got a lot of code reuse on the client as well, because to implement pushState, we just added 2 new JavaScript modules. So our changes were purely additive in nature, and they were limited in scope just to those 2 modules. And lastly, because we weren't going to be modifying our existing URLs, it really met and was in sync nicely with our content accessibility requirements. And so in this way, you can think about progressive enhancement in sort of the vein of Bruce Lee's "be like water" mantra, where, like, again, should the browser be able to take advantage of pushState? It does. If it doesn't, then the content takes the shape of the abilities of its container effectively, just like water does. Okay, so going back to goals. So again, we saw the transparency thing, and then I told you about how it was able to save us this re-architecture cost. It's worth mentioning that depending on your site or application, if you're looking to implement pushState navigation, there may be some re-architecture required, mostly with respect to how your JavaScript is organized. And by that I mean, if your script isn't already organized in a modular way that can be loaded asynchronously, that is a re-architecture cost you'll have to bear. Having said that, that is not unique to our particular implementation of pushState. It's going to likely be a cost you'll have to bear regardless of your implementation. If you're interested in more of the nitty-gritty details of our approach, we author our modules in CommonJS format, and then we have a build process that wraps those in AMD. And then on the client, our loader dependency manager is LoadRunner, which was written by Dan Webb, one of our team members, and that's an open source project on GitHub. So that's what we use on the client. A little bit more of a deep dive on what we had to do server-side to implement this progressive enhancement approach to pushState. So, like I said before we had our pushState implementation, we had a website that the user would navigate around as they normally would, old school way, click on a link, full page refresh happens, and we had our templates. We have our templates rather in Mustache, which, if you're familiar with Mustache or any kind of templating system, this shouldn't look hopefully too alien. So we have the full HTML wrapper for our view. We have keys that are populated with data from the server, And then at the end of our page, we have a using directive, which is our load runner syntax for bootstrapping the JavaScript modules that are associated with that particular URL. And then the server also gives our JavaScript a JSON object that is effectively like a state object, so the JavaScript knows what state it should be bootstrapping itself into for that particular URL as well. So this is what we started with. And so then when it came to implementing pushState, the first thing we had to do was say, okay, server, if you get a request that is a pushState request, which you could key off of any number of things for, we chose to check the accepts header for application JSON. You could check X requested with. You could use a custom header. You could have the client send a custom header, rather. But all we effectively do, and in the simplest fashion, is that if it's a pushState request, we take the existing server-side rendered content view, we wrap it in JSON, and then we send that back to the client. If it's not a pushState request, we just carry on as we normally did before, sending a full page request. And the JSON version, or the JSON wrapper for the pushState request, effectively just reuses all of the existing data that we were already sending for the full page request. It's just less of it. So we send the content view in a page key. We send the path to all the JavaScript modules for the requested URL in a module key. And the initialization data for those JavaScript modules is in an init data key, and then the title for the page, and there's some other stuff in there as well. But when it comes to code reuse, and if you look at the pushState template on the server versus the full page template, you can sort of see the code reuse as you look at those two things side by side, where we're just repackaging the same data in a different form, depending on what the client wants. The last change that we needed to make on the server was for all the templates, any link that we wanted to facilitate pushState navigation for, we added a class that the JavaScript could key off of to intercept the click on the link and prevent default, and then make the Ajax request. This could be whatever class name you want to choose. We chose JS-nav. That's what we went with, but again, that's at your discretion. So that's our set of server changes. On the client, what we did, like I alluded to a little bit earlier, is we added 2 new JavaScript components into our existing client-side framework. So one that was designed to facilitate everything to do with just updating the UI for pushState and managing the clicks on all the links. And then a data component that was responsible for communicating with the server and firing events back to the client so the client could update in response to requests for navigation. So with respect to the client-side component, it binds a document-level click event listener that is a delegated listener, again, that looks for that class name of JS-nav. And it does something that is fairly straightforward, which is it checks to see, does the target of the event have this class name? If it does, prevent default. And then what it does is it uses jQuery, triggers a custom event, which we specifically called UI navigate, and it triggers that custom event with the path to the URL that the user is trying to navigate to. At this point, the data component that's also listening on the same page for that UI navigate event picks it up, and it says, okay, the user is trying to navigate to this path. It makes an Ajax request for that particular content. And when it's done, I'm sorry, I have one more slide up there that I forgot to tell you about. Any conscientious developer that is intercepting clicks on links probably already knows this, but it's worth mentioning that you'll probably want to ensure that it's only traditional left clicks that you're intercepting and navigating. So you'll probably have something similar to the code that we had to write, which is to ensure that it's not a right click or that you're not breaking context menu behavior, et cetera, et cetera. Okay, so back to the data component. So the data component is listening for this UI navigate event that the client code, or I'm sorry, the UI component is firing. Does an Ajax request for the specified content, and when it gets that content back, it triggers another custom event called data page refresh, and it passes the response in as one of the arguments to that event. Then back in the UI component side of things, it's listening for that data page refresh event fired by the data component. And when it gets it, it says, okay, so we've successfully retrieved the content for the specified URL. It updates the DOM with the server rendered view, just using jQuery's HTML method. And then it uses, again, our client load runner, that using syntax is load runner syntax, to fetch the JavaScript modules that are specific to that particular endpoint, and then passes in the initialization data again from the server for that endpoint as well. And the last thing the client, the UI component of the pushState navigation component does is it triggers a custom event called UI page changed, and that allows any other existing UI components in our client framework that need to be aware that a navigation has happened to update their state in response to that. So a very simple example of that would be our global navigation and like the title bar for the page, which would need to be updated in response to you moving from home to connect. You want the title on the page to say connect instead of home. And so any component in our ecosystem can listen for these custom events. So the top nav component listens for UI page change, and it updates the document.title in response to that. So that's just one very simple example. I alluded earlier to the need to use pushState to manage the creation of a state object that is representative of that initial navigation that the user would have done to your site without pushState, so that when we return to that point in time that you can actually reconstruct state when you get that pop-state event. Here is what the implementation for that looks like sort of in code. We just keep a state variable, like I said, in JavaScript, in closure scope that says, have we done the initial push-state navigation, yes or no? And then if it's true, this is our first push-state navigation, we call replace state. The client code looks at the DOM, it extracts part of the content view that would normally have come from an Ajax request, knits back together a bunch of other things that we're going to need to reconstruct that state later, calls replace state, pushes that state object onto the history, and then we facilitate forward with the push state navigation so that, again, when you hit back, we have a state object on the event that we can use to reconstruct state. Two other interesting problems that we ran into with respect to the pop state event. The first, actually, they're both specific to WebKit. As it turns out, WebKit will fire a pop state event regardless of how the user navigated. So if you just open up Chrome, for example, and type in apple.com and add an event listener for pop state, you'll see a pop state event fired even though you didn't navigate to that page via push state. And so your pop state event listener is very likely going to have to just do a simple check for, is there a state associated with this particular event, and ignore that, so you're not handling null pop state events, right? So that's fairly straightforward. Where this gets just slightly more complicated is if the user starts off on some page on your site, they do a push state navigation, then they leave your site, go to not twitter.com, apple.com, Google, whatever, what have you. What happens then, of course, is that your state is completely destroyed because they've left your page and they've gone elsewhere. But because of this bug in WebKit, what's going to happen is when you hit back, you're going to get a pop state event. Your client code is going to get a pop state event. But because you're going back in time to a page that the user did navigate to via push state, you're going to have a state object associated with that event. And so but at the same time, your application will have just bootstrapped itself off of a full page reload because the user hit back and it has to reconstruct everything from scratch because it was totally torn down when it left your domain, right? So you'll want to have some code that thoughtfully manages this superfluous pop state event. So the best solution I've found for this so far, and I'm sure there are going to be evolutions on this if this bug in WebKit remains, is to bind a before window unload event listener that basically just destroys the state associated with that current URL before the page just gets deconstructed. And replace state is really, really useful for this. So this is almost exactly what the code does on Twitter. We just call replace state for the current URL and just put null into the state object. And that way, our pop state event listener can uniformly handle null pop state events using the aforementioned technique. Some other interesting notes about our implementation is our JSON responses for push state send back some other useful data to the client so that it can make some decisions about things. The first of which is whether the client should facilitate push state navigation or not. That ends up being a joint decision between client and server directed by the server. So the server tells the client, you should try using push state. So the push state response has this key in it, push state true. And then what happens is the client code gets this. It looks at, OK, I'm supposed to use push state. And then it does a browser capability detection on top of that. And if the server says it should be using push state and the client is push state capable, then it initializes the push state UI components. Otherwise, they're not initialized, and we don't end up loading components that the browser can't use or the server says that the browser shouldn't be using. And this also becomes useful because that means we can disable push state at any time if we're ever experiencing any problems and we want to go back to regular full page navigation. Our success event listener for any push state navigation can check the push state response, and if the directive to use push state is now off, we just do a full reload to the specified URL the user is trying to navigate to. But the nice thing is, because we didn't change any URLs when we implemented pushState, that change is transparent to the user. They still go to the URL they were attempting to, they just didn't navigate there via pushState. So it's a nice way of handling errors or just having the server be in control of what's happening at all times. One of the other interesting decisions we made was that the server can tell the client only update a sub-portion of the view. So we passed this view container property, which is basically just a reference to an ID in the DOM that represents the parent container that should be swapped out when a pushState navigation happens. So by default, our view container is everything but the global nav. So if you start pushstating around, we replace sort of most of the body of the page. But for certain pages, like a given profile page on Twitter, where it's mostly the same content, and when you navigate between the items in the left nav, all you're doing is swapping out the timeline below, we specify the view container to be even more narrowly scoped, for example. Some other interesting uses of just like taking advantage of the fact that we didn't change any URLs and how that allows us to like forcibly reload the client at any time. So I already talked about how the server can disable pushState at any time, and that just forcibly reloads the client. We can also do things like if the client and server versions are out of sync during a deploy, the client can just forcibly reload and bring itself back into sync. If in any way the JSON response is malformed and there's a JSON parse error and we can't facilitate the pushState navigation, we just forcibly reload to the URL specified and the user navigates there anyway. So it ended up being a nice, easy means of handling errors. And like I said, we found that this gave us a number of benefits, and just to sort of wrap up what those were, it gave us faster navigation between pages, and that was one way of facilitating that. There was a bunch of others that we've been working on. We also found that this implementation was nicely robust because the URLs don't change, like I said, regardless of how the user is navigating. And because of the amount of code reuse that we got on the server and that our JavaScript changes were mostly additive, adding these two new components, we found that it was a nice, low-cost, high-yield implementation of pushState. So that about wraps it up for everything that I had planned to talk to you about. Happy to take any questions you have now.
So
yes?
when you do pushState, do you go back to the server and grab the latest HTML, or the browser just basically render whatever is saved?
Sure. So the question is, when we handle PopState events, do we go back to the server for that information, or do we just handle what the client has? And what we have is the server sends a TTL on our pushState responses, and the client caches those responses. And then if they fall out of cache, then we go back to the server.
But normally you just grab it from the browser.
Yeah, exactly. Yes.
So say you have a web app that's a single-page web app, like the majority of your stuff happens client-side.
Yep.
Would you then have to implement something on the server side to take advantage of pushState? Because if I'm a client and I navigate to a URL that I don't know how to handle, obviously it's going to result in 404. So
Okay.
Is that something that you guys ran into?
So the question is, let me make sure I'm phrasing this right. I have a completely client-driven app, so something like maybe analogous to Gmail or Yahoo Mail or something like that, and I want to implement pushState. Does any of the challenges that I've talked about today apply?
Yeah, so you obviously have server-side templates that you're serving out. I
Yep.
necessarily wouldn't in a single-page web app.
Yeah.
So is that something that you have to sort of re-architect so that you can take advantage of pushState on the back end, so that I can send whatever HTML markup I need to render on the client side?
So you might recall in this like the amount of server changes that we had to make, it was mostly, we were not a single page web app to begin with. Let me sort of,
I guess
yeah. So I think we're probably approaching it from different problems. I think the simplest answer to your question is, number one, can I use pushState and still do client-side rendering? Of course, it does. It's sort of like you can do it either way. This is just the implementation that we took. So yeah, if you want stateful URLs and you want to continue forward with client-side rendering, then this is an equally nice solution for you. And then I think we could probably talk about the second part of your question offline if you want to. Yeah, but I'd be happy to talk to you about it. How about in the far back?
Hi, I work on a single-page app that still uses hashtagging, and we have this one class of bugs
Yes, yeah, I did hit that. And the way I got around that was to, when I get the response from the server, it's taking advantage of basically closure scope. I know the original path of the last clicked link in closure scope. And so I can basically just do a comparison again. It's like, this is the last thing that the user was trying to navigate to, and this is the last response I got. And I only trigger that custom event that tells the client to update its state when those two are in sync. And that way the client is basically just throwing away responses that are not in sync, if that makes sense. How about on the end right here? Yeah.
So what do you think of history.js and things like that? All these folks.
What do I think of history.js? I would say that if it solves the problem for your application, then use it. As I understand that, like backfills for push state with hash bangs or hashes. I don't think it's necessary. That's just our opinion based on our implementation. I think that's pretty clear from the presentation. If you haven't already read that article, though, by Benjamin Lupton, I think that would probably, if you're trying to weigh the decision on whether or not to use history.js, I think that would be a very definitive answer for you. Yes?
You mentioned how you have the server decide which clients should try to use pushState. How are you resolving that? Are you doing it with like user agent detection or something?
Okay, so the question was, I mentioned before about how the server sends a directive to the client whether or not it should use pushState, and are we doing that via server-side user agent detection? No, so just to sort of revisit that point, what happens is the server basically just sends a directive to the client that says, you should attempt to use pushState. And then the client says, okay, I will if I can, and then it's a two-pronged decision, which is the server told me I should, and can I? So we do client-side feature detection, and then furthermore, we on-the-fly bootstrap those pushState components so that we don't preemptively load them if we don't need them. So, yes, on the end. Oh, yeah. Oh, yeah. Actually, that's in the slide deck. It's very early on. Best practice. So the question was, do you have best practices for intercepting clicks on links? And the best practice is generally to not break the expected behavior. So we only try to push state navigate if the user is doing a traditional quote-unquote click on a link, so a left click. If they attempt to do a context menu or right click or anything like that, we just honor that and we don't do a push state navigation. And the code for doing that is in the slide deck.
So what happens on the instance? Do you open another instance like you would normally would?
Yeah. So we just pass it back through to the browser. We don't do anything with it. Yeah. In the middle?
Do you run any gotchas
Oh,
or
I'm sorry.
issues with handling page views or tracking?
Okay.
User flows, where someone goes, how do you trigger it?
So how are we handling tracking? Actually, it wasn't too bad because if you remember, our client architecture is such that when we are doing push state navigation, we're triggering custom events that are happening. So and furthermore, because of the custom event architecture, and event bubbling, our push state components are triggering events into the ecosystem. So our existing tracking components can also listen for those custom events and then proceed as they normally would had they been tracking like standard quote-unquote clicks. That's like the high-level summary of what we did. Okay, I think I have time for one more question, so how about you? The question is, do we maintain two different templates on the client and the server? We don't. All the templating is on the server, and all the views are rendered on the server. So when we handle push state responses, the part of the response from the server is a server-rendered view of that particular page wrapped in JSON, so that the JavaScript, all it needs to do is say, give me this, take this HTML out of the JSON response, and just call inner HTML on the specified node that we need to update state for on the client. Thank you for coming.